Compression members or struts are those structural members who resist axial compressive forces. If a member is truly vertical, it is called a column. In steel, columns are also called stanchions. An inclined member who takes axial compression is called strut. Columns or vertical member can take load with eccentricity or not, however provision of minimum eccentricity is always there in calculating strength.
Classification based upon type of loading. Axial loaded columns. If applied load lies upon longitudinal axis of column. Eccentric loaded columns. If external load is at an distance to cg of cross section. Eccentric columns are further classified depending upon their bend or buckle about an axis. 1. Uniaxial bending. If load is eccentric with one axis only. 2. Biaxial bending. If load is eccentric to both axes. Slenderness ratio. The slenderness ratio of compression member is defined as the ratio of effective length to the least lateral dimension. The columns may be classified further according to slenderness ratio. First is pedestals. If the ratio of effective length of column and least lateral cross-section dimension of the column is less than 3, the column is called pedestals. They fail by crushing and have uniform compressive stress over section. Next type is short column. For short columns, underlying points are important. 1. If the ratio of effective length of column and least lateral cross-section dimension of the column is greater than 3, but less than 12, is called short column. 2. A short column is assumed to fail under total axial compression force or axial load with provision of minimum eccentricity. The stresses over cross-section are assumed to be pure axial compressive stresses and can be calculated as sigma equals P upon E, where P equals axial compressive force, A equals area of cross-section. 3. The failure of short column is due to crushing of material. The load carrying capacity is high in comparison to long columns. 4. The slenderness ratio, which is equals to the ratio of effective length and minimum radius of gyration, is less than 80 for short columns. Next type is long columns. Following are the salient points for long columns. 1. If the ratio of effective length of column and least lateral cross-section dimension of the column is greater than 12, is called long column. 2. Under axial or eccentric loading, the long column fails by buckling. Buckling is always about an axis where the section has minimum moment of inertia. The long column behaves like beam under bending. The combined stress over an extreme fiber is sum of axial compressive stresses and bending stresses. The extreme fiber stresses are given by sigma C equals P upon A plus or minus M into Y upon I, where P equals axial compressive force, A equals area of cross-section of column, M equals bending moment due to eccentricity, equals P into A, Y equals distance of extreme fiber, I equals moment of inertia. Sigma C equals combined stress. 3. The slenderness ratio, which is equals to the ratio of effective length and minimum radius of gyration, is greater than 80 for long columns.
For complete course and step-by-step illustration, please subscribe full course on Structural Analysis and Design app. Also subscribe YouTube channel Matrix Digital Solutions. Thanks for watching.